So welcome to your big idea. Folks, we're gonna make some triangle segments in the sand. Let's go ahead, check it out. Alright, so we're gonna start with a triangle in the sand. Mission accomplished. So we got the triangle. Now we have to draw the altitude to the triangle. Remember, the altitude goes from one of the vertices of the triangle and hits the other side at a right angle. Alright, so now I'm gonna draw an altitude to this triangle. We're gonna start from this vertex of the triangle and we're gonna draw the altitude at a right angle to this opposite side. Let's go ahead and do it. And voila, we have the altitude to the triangle at a right angle to the opposite side. So let me see if I can draw the right angle. Here's your right angle, and boom, here's a triangle with an altitude to its opposite side. Today I'm going to help you clarify all the triangle segments. So we got four kinds of special line segments. The median, right? So the median, it starts from a vertex of the triangle and chops off the opposite side in half. That's all the median is. So let's remember that by writing median. And you can remember the median by thinking of middle, right? It chops the other side in the middle. The next one up is this one. Hopefully you can identify what it is just by looking at it. Just by noticing this right angle, you should think of the word altitude. And altitude starts from a vertex of the triangle and hits the opposite side at a right angle. The perpendicular bisector, what it does is it chops off some side of the triangle in half, and it does so at a 90-degree angle. So imagine I want to chop this side in half at a 90-degree angle. Well, I do it with a perpendicular bisector. What the angle bisector does is it chops angles in half. The median chops sides in half. The angle bisector takes an angle and chops it in half. And so we call that the angle bisector because it bisects, get it, an angle. Okay, now we're going to go ahead and look at some examples for each of these four special segments in triangles. Let's check out some examples. So here I've got a triangle, and I'm going to say the bottom side of the triangle is 20, let's say. Now I'm going to draw the median starting from the opposite vertex and drawing the median. And now I want to know how long is this segment of the triangle? How long is this little segment here? Well, since the median chops off opposite sides in half, this would be 10, and this other segment would also be 10, and they'd add up to 20. So that's all the median is. Let's check out an example of the next one, which is the altitude. Alright, so here's a triangle. Now I'm going to draw the altitude. So here's my altitude starting from the vertex and dropping down to a right angle. And let's say that this is D, point D here. So it drops down to point D. Now my question is, what kind of triangle is this triangle? Triangle ADC. What kind of triangle is it? Well, just by knowing that this is the altitude, you know it's going to hit at a right angle. So this triangle is going to be a right triangle. It's going to be a right triangle. But there's more to the altitude than that. Here's another way you can use the altitude. Let's say I tell you that line segment AD is an altitude, and this angle C here is 30. Well, what would this angle be? Well, you might think, hey, I don't know enough information to answer that question. But check it out. You know that the altitude hits at a right angle. So this is 90 and this is 30. And you know that a triangle has to add up to 180 degrees. And we know that the triangle already has a 30-degree angle and a 90-degree angle. So what would this last angle have to be? Well, for it to add up to 180, my last angle has to be 60 degrees. So that's how you can figure out this angle is 60 degrees, just by knowing that this is an altitude. See how useful it can be? Let's check out the next line segment. So the perpendicular bisector can be pretty confusing. So let's check out an example. Let's say I have a triangle right here, and let's say I have some sides to this triangle. Let's say, I don't know, this side is 17, this side is 16, and this side is 15. Okay, so I've got a scalene triangle, and let's say I draw a perpendicular bisector to some side. So let's say, boom, there's my perpendicular bisector. Now, here's the question. If that's a perpendicular bisector, how long is this purple line segment? Since this is a perpendicular bisector, it's going to chop this side of 16 into two line segments of 8 and 8. Okay, so this part of the triangle is 8, this part of the triangle is 8, it adds up to 16. All nice and good. So that's how helpful the perpendicular bisector can be. Let's check out the last one, which is the angle bisector. Now let's say that angle A is 60 degrees. Now let's say I draw an angle bisector here. So here's my angle bisector. It starts from this vertex of the triangle, vertex A, and drops down. Now the angle bisector is going to bisect angle A. So it's going to chop up angle A into two equal angles. The question is, how much is this angle? How much is this angle? Well, to answer that question, just remember the angle bisector cuts angle A in half. So this remaining angle would just be 30 degrees. And this one would be 30 degrees. And so they add up to 60 degrees. That's why the angle bisector is useful. Now let's check out an example of one of the four special segments in a triangle. Our example. In triangle ABC, segment BD is drawn such that D lies on AC and BD is perpendicular to AC. Question is, what special segment is BD? Whenever you have these kinds of geometry problems, first thing you gotta do is draw a picture. So there's some kind of a segment BD in my triangle. So I know one of the endpoints of that segment is B. The other point is, somewhere here maybe. So that's segment BD. And BD is perpendicular to AC. So AC is this one and BD is this one. So I should draw BD so it looks perpendicular probably. So here is BD, okay? And perpendicular means it hits the other side at a right angle. So here's the symbol for a right angle, aka 90 degrees. So what type of special segment is BD? Well, whenever you have something that's a line segment that starts from a vertex and hits the other side at a right angle, well, you have an altitude, right? That's what an altitude is. That's the definition of an altitude. So BD is an altitude of triangle ABC. Here's our next example. In triangle ABC, line segment AD is drawn such that angle BAD and angle CAD have the same measure. What special segment is AD? So this is pretty weird, right? I mean, I don't know what this is saying, so I gotta convert this to pictures. Remember, draw a picture. So let's draw a picture of the scenario. We have a line segment AD. So what does AD look like? Well, that's gonna start from vertex A, and it's gonna be a line something like this. So that's AD. Hopefully you can see AD. And you have two angles. One is angle BAD. So let me highlight that for you. BAD. So that's gonna be this angle. You see that? That's gonna be that angle. So let me go ahead and draw in that angle. The other angle is angle CAD. So they have the same measure. Bottom line is this angle and this angle have the same measure. And so we want to know what kind of line segment AD is. So if this angle and this angle are equal to each other, that means the bigger angle here was cut in half, right? So that means line segment AD is a special kind of line segment that cuts angles in half. So line segment AD took this angle, it cut it in half into these two equal angles. And so line segment AD must be an angle bisector. And that's it, folks. Now let's check out the big idea. Alright, so here's your big idea. First of all, we've got this big table. So you have to go ahead and fill it out, right? So the median, does it pass through a vertex? Does it go through a midpoint? Does it form a right angle? And can you draw a picture of all of this? For all four special segments of a triangle, you're going to go ahead, fill out this table, and then what type of special line segment is shown in this diagram. So good luck with the big idea, and if you need any help, watch the small and big hints.